Next up, we are talking about arc and arc length. So an arc is a shape like this. It's kind of like a line, except it's curved. And our job is to find the length of it, or how long it is. Normally when I want to know how long something is, I take a ruler of some sort, like I have on the side of this protractor, and I would try and measure. But the problem is that I really can't measure a curve against a ruler. It doesn't work. So I need to visualize this arc as part of a circle. So hopefully you can see here that this arc matches along the outside of some circle. So it happens to match this circle. I'll put my center in there. So the arc is a portion, this section here is a portion of the circumference of the circle. So if I want to know how long this portion of the circumference is, this arc, I need to know both the circumference of the whole circle that could be made from that arc, and I need to know how much of that circle I'm looking at. So I need to look at that portion of the circumference. So similar to what we did with sector areas, where we thought about the slice of pie and thought about how much area would be taken up, with arc length, we're thinking about this same slice, but we're talking about what portion of the circumference do we have. So first, we're going to find the area of the whole circle's circumference. And then second, we'll think about what portion of the circle do we have. I'm not trying to go all the way around the circle, I'm just trying to go that far. And how long is that? So we're going to be looking at our same three shapes from that sector area video. We have our semicircle. And so to find the arc made by a semicircle, right here, I would find the circumference of the full circle and then cut it in half, because I only need to go halfway around. For a quarter circle, I need to know how far is it to go a quarter of the way around the full circle. So I would find the circumference of a full circle of that size and then divide it by 4 to find just that portion. And finally, if I want to know the arc formed by 3/4 of a circle, I would find the circumference of the full circle as if I had everything. I would cut it into 4 chunks, and then I'd keep 3 of them, or multiply by 3, one chunk by 3, to figure out how long it would be around. So we'll do a few example problems to see that in action. So I'm being asked to find the arc length of each partial circle. So it's not a full circle. We could call this area, this sector, but we're looking at how long is this part of the circle. And that's a portion of its circumference. So the first thing I would do is think about the full circle. And I just sketch it in. Okay? And I'd think about how would I find the circumference of a full circle. Circumference has a formula, 2 times pi times radius. So I'd look at my circle and I'd figure out, are there any of those pieces I can fill in? So So yes, in my problem, they give me the radius is 6 centimeters long. So in my formula, I will fill in 6 for my radius, and I will do 2 times pi times my radius of 6. In my calculator, I'll type in 2 times 3.14 for pi. We're going to use a rounded version, and then times 6. And when I do that, I get the answer 37.68. So if I were going all the way around the circle, I would go 37.68 centimeters. But because I'm only going a quarter of the way around the circle, I need to cut that number into 4 pieces. So I need to find a fourth of it. So 37.68 for my full circumference, and then divided by 4 will give me just that portion. So when I do that, 37.68 divided by 4, I get 9.42 centimeters. So this portion of the circumference here, if I just measured that much, that would be 9.42 centimeters. All right, we'll look at a couple more. Next, number 2, so finding this arc that's formed by this portion of a circle. So when I'm looking at this circle, I'm thinking, okay, this looks like half of a circle or a semicircle. So I'll keep that in mind. But I need to figure out what would be the circumference, this is a really messed up circle here, of the full circle first. So the formula for circumference is circumference equals 2 pi r. And I'll look at my picture and I'll think, okay, well, they didn't mark a radius here. They didn't show me from the center of the circle out. They showed me that this line going all the way across, my diameter, is 25 meters. So I can think about how a diameter relates to a radius, and it's twice the radius. So I'm actually going to use that other formula that we talked about for circumference that kind of incorporates the 2 and the r together, the twice the radius, which is the diameter. So my circumference we could also think about is the diameter times pi. Rather than twice the radius times pi, it's just the diameter times pi. And that's what they happen to give me in this problem. So that's why I'm doing this. So I'll take 25 and I'll multiply it by 3.14, which is pi. And in my calculator, when I do that, I get 78.5. And I'll use the same unit they're using, so 78.5 meters to go all the way around this circle. But I'm not going all the way around the circle, I'm only going half of the way around the circle, so I will take, for my half circle, I'm going to take my full circle's circumference, 78.5 meters, and I'll divide it in half to get half the circle's circumference, or that arc length. And when I divide it in half, I get 39.25 meters. So if I just traveled this halfway around the circle, I would go 39.25 meters around. Okay, our last problem. We have this shape and we're trying to figure out how far would it be to go from here all the way to there. So as always, I'm going to start by drawing in that full circle so I can think about the full circle's circumference. So for the full circle, its circumference, we could use the formula 2 pi r, or circumference is pi times diameter from above here. Both work. But in our circle, they give us a radius going from the center out. So I'm going to use the formula that has radius in it. And I'm going to fill in that formula with the radius of 3 inches. Because that is what they measured. And in my calculator, I'll type in 2 times pi, which I'm using 3.14, times 3. And when I do that, the full circle is 18.84 inches all the way around. So a full circle would be 18.84 inches. But of course we don't have the full circle. They're actually only asking us to find that much. So by now, hopefully you recognize that they're asking us to find 3/4 of the circumference, right? We're only doing those 3 shapes. So you're only responsible to know the 3/4, the half and the 1/4. So to find the 3/4 of the circumference of the circle, here's what I would do. I would take this 18.84 inches and I would divide it into 4 equal pieces to figure out what each of these sections are themselves. So I'd find 1/4 of the circumference. So I would do 18.84 and I divide it into 4 pieces. And I would get that each piece is 4.71 inches. So every little section here is 4.71 inches because I took the full circumference and broke it into those 4 pieces. And then to figure out the pink section, the pink circumference, the arc we're looking for, I would take that number, 4.71, and I'd multiply it by 3 because that's how many I want to include for that pink arc. And that would give me the 3/4 of a way around a circle. If I do that in my calculator, I get 14.13 inches. And that would be how far I would go if I traveled just that amount around my circle. By now we've covered all of the major concepts we're going to think about with circles. So finding their circumference, their area, and now looking at portions of the circle, half a circle, 1/4 of a circle. Could we find its area and circumference of just those portions? So today you're going to practice with finding arc lengths of these parts of circles. And I look forward to seeing how you do. Let me know if you have any questions.